Okay, so this is just a little add-on to what we did on Friday using base E um, growth functions. So we knew that the number E came from 1 plus 1 over n to the nth power as it approached infinity. And so you can kind of see it in there if r is 1. You can see that it's inside of there. So basically what happens is as n approaches infinity, as n gets larger and larger, then that what's in those parentheses ends up, well, except for the r, ends up going to E. So the formula that you need to know then is just that the amount is going to be the principal times E to the RT. And make sure you remember that the rate has to be as a decimal. Just like before when we did these. So continuously compounded is, it's like an abstract concept. Continuously compounded is not something we ever really can think of in terms of like how many times a day you're compounding it, but it's just like it's being compounded infinitely. So we can use this formula though then to figure out how much it would be if it was compounded continuously. So for example 1, we're going to deposit $4,000 into an account and it pays 6% annual interest and it's compounded continuously. What's the balance after 5 years? So first of all, let's identify what goes into the equation here. So what is the $4,000? The principal, or P, right? And what's the 6%? The rate, but how do I have to do it? As a decimal, so what is it? 0.06, yep, divided by 100. And then finally we've got our 5 years, which is the time. Okay, so if I do A equals P E to the RT, that means I've got $4,000 times E to the 0.06 times 5 power. So if you just multiply those two together, 0.06 times 5, it comes out to 0.3. So in your calculator, you're just going to put 4,000 times E to the 0.3 power. Why don't you guys do that, see what you get. All right, so it looks like we were all getting the same thing there. 5,399 and 44 cents. Okay? Just like that, you got an extra $1,400. Okay, so here's one for you guys to do all by yourselves. And yeah, just do it on your whiteboards. Okay, so we ended up getting $3,332.13. All right, so you got a chance to redeem yourself. Here's another one. You deposit $4,500 in an account that pays 2.3% annual interest compounded continuously. What is the balance after 5 years? Okay, so we came up with $5,048.43. Now what I want you to do is work backwards and figure out how long it'll take you to double your money. So what do I mean by work backwards? Start plugging in different periods of time. Just guess and check, basically. How much money do you have in 10 years? How much money do you have in 20 years? Guess and check until you have close to double your money. So what would double your money be? $9,000. 4,500 times 2.
You mean from the original number?
From the original number, yeah. So from the original deposit of $4,500, how long will it take you to get to about $9,000? Okay, so now you got to work backwards a little bit. Okay, shh, keep it to yourself until everybody else has a chance to figure it out. We're saying about how long. So when you got to 30 years, it wasn't quite enough yet, and when you got to 31, it was a little bit over. So somewhere between 30 and 31 years.
30.5.
Okay? Yeah, you could try 30.5 and get it as close as you want if you want to. We are going to eventually learn, though, how to solve those exactly when we get into logarithms. But for now, we'll guess and check. All right, that's it for today. It was